Dream to become the next Sir Isaac Newton or Albert Einstein? Learn from the master, Refath Bari. Watch his videos to achieve your dreams.
The next lecture on linear algebra. Today I want to start shifting our focus away from dot products and Cauchy-Schwarz inequalities back to our original focus, which was linear equations. Now my do now is designed to bridge the gap between dot products and linear equations. So let's go ahead and get started with the do now. Okay? So this do now is hopefully a little bit of a challenge.
Why are you blocking?
Oh, sorry. Find the theta, the acute angle.
Instructor, don't block.
Yeah. Find the acute angle between two lines, and let me give you these two lines. 2x minus y equals 3, and x minus 3y is 4. Okay, so what am I asking you to do? I've just given you two lines, and I want you to find the angle between them.
Sorry, can I do it?
Yeah, go ahead.
They literally said acute.
So,
And will you say that is acute? What is wrong with you? I'm clueless what you've done, but it's weird. What have I done?
I'm not quite sure what I'm looking at here, but it certainly looks like progress. Now, why don't we go ahead and get started by looking at some simple charts to get started with the problem. So let me invite our other student. Maybe he'll have some ideas to
So
approach
we
this
start
problem.
rearranging the equation.
Go ahead and
Y equal to 3 minus 2x. So minus 2x plus 3. So that would look a bit like this. And then this rearranged is 3y equals to 4 minus x. No. 3y equals to x minus 4. So y equals to x over 3 minus 4 over 3. So x over 3 minus 4 over 3, I would, excuse that, expect to be a bit like,
Well, it has a positive
bit
slope, so
fat.
be careful. It has a positive slope,
yeah.
so
So
and a
it
negative
would-
y-intercept. Yeah, something like that.
be
Okay,
like
so
that.
that's
So that's acute. No, that's obtuse for
this
what I
one.
can.
This-
Oh,
Okay, so
this.
that's a great first step. Whenever you don't understand a problem, try to approach it in a different way. Our student here has approached it visually, and just to make it clearer for you, maybe I can make his drawing even.
Excuse me, instructor.
Sure. So one of our students has identified the drawing we need to get started with the problem, and I want to enlarge his drawing for the rest of the class. So why don't we go ahead and draw exactly what our two students here have drawn. So maybe
Instructor, this marker is bad.
yeah, I realized.
This marker might be
No,
bad.
that's bad. That's bad.
No,
Okay,
look at this. It's good.
Okay, so why don't we get started with just our regular Cartesian plane, right?
Cartesian plane? I never knew what you call that.
Okay, so first and foremost, what I want to do is graph our two lines. As you can see, our two equations here are written in slope-intercept form. That's going to enable me to find the
Wow.
So that's going to enable me to find the intercepts of the line very easily. Okay, so my first line, 2x minus y equals 3, I can draw it very easily. How? Well, let me identify the intercepts. What is the y-intercept of this line? Well, if I plug in x is 3 over 2, I can simply see that that is my y-intercept, right? We all agree.
And
that,
if you do that,
this is my
and if you
x-intercept,
set y equals 0, yeah, you get 2x equals 3.
and this is my y-intercept, right? So we agree with our intercepts for the first line, right? So why don't we go ahead and draw these intercepts on the graph, so we can plot
I
our
think
line.
you need the.
Okay.
I think you
So
need the
3 over
negative
2.
x-axis as well.
3 over 2 is somewhere here, and the 3 over 2 is our x value, and minus 3 is our y value.
Oh, mind if I write the x and y intercept of 3?
Go ahead, write the x and y intercepts for that line.
If you're willing, so negative 3y is 4, 0, comma, negative 3/4.
Okay, so our other student has identified the x and y intercepts of our second line.
Oh.
As you can see, the x-intercept is 4, so we're going to draw 4 over here. So let's put 4. And the y-intercept is negative 3 over 4, which is going to be somewhere around here maybe. Somewhere around here. So my other line, maybe I can draw it in some other color, or I'll stick to my green. So my other line is going to look something like this, right? And I see my two lines intersect at a common point. Okay, and that common point I've identified in green. Now, what is my question? My question is, find the acute angle between the two lines. Now, do you guys see where the acute angle is?
Yeah, these two acute angles.
Exactly. So our question is to find this theta right here. That is our goal, to find this angle between the two lines. And we will try to do so using vectors. So, how can we get started solving this problem using vectors?
Well, we could find the slope and make a vector out of that.
Right. Well, let me show you. Why don't we treat these points as vectors, okay? So, I have a point right here, and I have a point right here. So, I can draw a vector like this, right?
And the vector would be
So,
4 in the x, negative 3, 4 in the y.
what will the components of my vector be? Well, I'm going 4 in the x, as our student here has suggested, and I'm going 3/4 in the y.
Negative 3/4. Right?
Positive
Oh,
3/4.
yeah.
I'm going from 3/4 up to 0. So that's going to be the components of this vector. What about my other vector?
I think you said illustrated using blue instead.
My other vector, I'll draw in blue.
Oh, Alex is colorblind? Oh.
So my other vector is going to be the following. Okay? So what am I doing? Well, as you can see, I'm going 3/2 in the x direction. So my x component will be 3/2.
And
I'm going up.
3.
How many units am I going up?
3.
I'm going up 3 units.
Alex,
Right?
you seem a little shy today. Why aren't you saying anything?
Yeah, I'm trying to understand
Okay.
it.
So great. Just so we can, slow down a bit, why don't we review what we've been doing? We started with 2 lines, and we wanted to find the angle between the 2 lines. So we identified the intercepts of both of the lines,
I think I
and
know.
we drew vectors to those intercepts.
I have a
Now-
very big light bulb. I think I know what to
Sure.
do.
What do you propose?
V dot W equal this cosine theta. And where we can solve for theta.
Wow. Well, as a matter of fact,
But we saw
was
this equation before.
exactly.
I was going to tell you. In
Uh,
fact, I wrote it down.
I highly doubt that, but
You just erased it. You copier. You plagiarizer. You!
so our student here has actually identified exactly the
You
equation
are a
we need.
plagiarizer.
And some
Big plagiarizer.
folks out there might think this equation was pulled out of thin air, but no, we are asked to find the angle, and hey, that's one of the parameters of this formula. So we can actually use this equation. So let's go ahead and try to use the equation for the dot product. So our student here is writing that equation down. And let's go ahead and
I did it.
and
I did it.
our other student has also done the same. So
Slow
he has solved
down,
for
my
theta,
dude.
which can be expressed as the inverse cosine of the dot product of our two vectors divided by the product of their magnitudes. This should be an easy formula because we've seen it many times. So why don't we go ahead and use it? Okay, I'll take over. So let's see. I'll go back to black. So let's see. So theta equals, or you know what, let me just start from the basics. Okay, so the dot product of my two vectors is going to be none other than the product of their magnitudes, times cosine theta. So we agree with this definition, right, class?
Yeah.
Do we
Yes.
agree?
Yes. Yeah, we do.
Okay, well let's take the dot products of our two vectors. What is our vector v? Our vector v is 3 over 2. And
Is
3.
this a lesson or do now?
Oh, this is lesson. We're almost done.
Oh. So can you change the do now to lesson? I was
Yes.
scared.
No
But
problem.
this is kind of the lesson.
Yeah, so this is kind of our lesson. The do now was finished when we identified the intercepts.
Oh.
Thank you for catching that mistake.
Okay.
So now, why don't we go ahead and take the dot product of our two vectors.
Dot product.
So I
Wait,
have
what about the
one
magnitude?
vector here.
What about the magnitude?
That comes later.
Oh yeah.
And what are the components of my second vector?
4, 3, 4.
Yeah. Oh, okay. Yeah.
You can do it.
Okay. 4, 4, 3, 4.
And,
Okay. Yeah. Okay. So why don't I? Okay, sure. Go ahead.
Okay, you can do it.
No. Show me the magnitudes of both of the vectors.
6.
Oh, can you show how you got 6?
Oh,
Because people don't know how.
3 over 2 times 4. So, plus 3 times 3 over 4. So that's 9 over 4. So that's equal to 33 over 4.
Okay, so let's see. Let's see if our student here is right. So here we have 3 over 4, which gives us 6, and 9 over 4, which indeed gives us, let's see, 24 plus 9 is 33. Yes, that is right. Okay, great. So we have the dot product. So we know the value of the left-hand side. Okay, we know the value of the left-hand side is going to be 33 over 4. 33 over 4.
Hey,
But we are not done.
I want to tell you something.
Yes.
I've been sanely writing the magnitude in the background. If you haven't been noticed. Been sanely writing these
Great.
all along.
So,
Ha!
our
I didn't
student here,
like that.
Oh no.
now some of you
Oh,
know,
but I wrote it.
Oh my goodness, you plagiarizer! Stop it or I will take your
So,
whiteboard and break
some-
it in half.
some of you folks must be confused how our student here got these numbers. Well, allow me to explain.
I've been
let me
sanely
explain.
Excuse me.
Yes.
I did it.
Alex has in fact done the very same thing. Remarkably, he has done it faster than our student here. So that's great news, Alex. So,
No, because he plagiarized me.
well, let's keep it a nice classroom. So let me explain
Yeah,
how
you
our
are gonna
student.
keep it a nice classroom
Yeah.
by eliminating the plagiarizer. Just like
So-
you're gonna do with the matrices.
So let me explain how our student here got the magnitudes, okay? So, to find the magnitude of a vector, recall that we take the sum of the square of its components. So I'll just show you how we do one. We'll take 3 over 2 squared plus 3 squared, and you'll see that gives us square root of 45 over 4. You can do the computation yourself. I'm here to highlight the main goal. Okay, so now you can see we're basically done with the problem. Okay, all I have to do is isolate theta here. So how can I do that?
Wait,
Well,
why don't we just plug everything into the thing we already had?
Sure.
Theta equal cosine inverse of our
our dot product, which is 33 over 4.
over.
divided by the product of the magnitudes of the vectors,
Yeah.
which is
Anybody have
which
a
is-
calculator, please?
Yes, I have a
which is
calculator.
33 over 4, all divided by square root of 45 over 4
Thanks, dude.
times
Best out.
square root of 73 over 16. Okay, and
Alex
that
always comes in class.
that is the answer. Now,
Wait.
you're probably thinking that this is not a very neat answer, but you know, mathematics isn't always giving you the neatest answer.
33
So
over
you know, you can find what this angle is on your own time. You should see that the answer is in fact acute and it is less than 90. So hopefully that has helped you understand how useful dot products can be, and you know, we've seen how dot products relate to linear equations. So now let me take you to a very easy exit flip where we're gonna try to build on this notion. Okay, so let's go to an easy exit flip. Okay, so okay. Okay, so let's see. Solve.
Can you erase everything?
Yes, I will. So the exit flip is very simple, hopefully. It's just to go ahead and try to solve that system of linear equations. And of course, you know, if this is your first time doing so, I'm afraid you'll have to revisit some of the old lectures. So if you don't know how to solve a system of linear equations, let me give you a few seconds to do so.
Oh, this is the one you want us to solve?
Yes.
So
The one we
2, -1, 1, -3, 3, 4. Okay, solve.
So, student Alex here has made some considerable progress. He's actually formed a coefficient matrix, which is ahead of the game. Today I'm simply going to be doing, you know, the old version, the old way to solve linear equations,
Oh.
which is something called elimination.
Okay. Can you give us few seconds
Sure.
or at least half an hour?
I'm afraid I cannot do that, but I'll give you a few seconds.
Okay, so I'll try.
While Alex is going ahead and trying on his
No,
own.
no, no, no. I want to try.
Oh, sure. So let's, I'll also provide you, the viewer, some time to practice this. And go ahead, try the answer. Try to solve.
I'm almost done.
Alex is almost done, he claims. And let's give the viewer some time to solve the problem.
Done.
And Alex has, wow, Alex has indeed found what I believe is the correct answer. And let me display his work. And let me actually do his work for the entire class, for those of you who do not know elimination. So, we're gonna, why don't we just start out by rewriting the problem. Okay, now first thing we're gonna do, multiply our second equation by -2.
I'm just kind of bored, so watching you guys do
Yeah,
this.
sure.
So I'll just clear.
Oh, no,
I'll
no,
try
no.
to clear it.
Okay. So why don't
Oh
we?
my goodness! How do you not know?
No, this is actually a very important concept we'll cover. Okay, so these cancel out. Negative and -3 makes positive 3. Now,
Wait.
Yeah.
Yeah, but it's my 2, so this makes 5.
yes, the multiplier was 2.
So
I should have said that.
5y equals
So 5y equals
-8.
-8.
5. Negative 5.
5. Okay, or so he claims. Now,
Why equals
why don't I
1?
check this? Y equals -1. Can we check that? So 2x
Yeah, that's.
minus 2x.
I got the same thing, so
Oh.
it's gotta be correct.
Alex got the same answer. So y is -1.
Wait, so
And can we get x?
2x plus 1 equals 3. So x must be 1.
As a matter of fact, that's right. X is 1 and y is -1. Now, before we end up finishing the lesson, let me introduce some key terms. See this 2y multiplied the second equation by? What do you think I call that?
Double?
I call it a multiplier.
Yeah, you just called it that.
an even more important word that we'll explore deeper in tomorrow's lecture. This 2 here is called the pivot. Okay?
But I thought the pivot is when you have a seesaw. That is the pivot in the seesaw, right?
Well, that's a physical version of a pivot, but here's a mathematical version of a pivot. In fact, they both share something same, which is they both act like balancing mechanisms. And we'll find out why in tomorrow's lecture. So stay tuned and thank you for watching.
Lever is the pivot, right?
Yeah.
Lever.
So it kind of acts like a balancing.
Okay.
So
All right. Okay, instructor. Thank you.
Thank you for watching, and we'll see you next time.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.